Hey class, this is lesson 513. This is an inquiry lesson. I'm going to get you started, but then we'll finish the rest in class. Show you how to do a couple problems. Basically, we're going to create some expressions and simplify them. So this first thing says, look at the shape, and it says on graph paper, draw an H shape in which A equals 1 and B equals 2 centimeters. So we're going to take the value of B here, and that length is 2. And every A, the length is 1 on the graph. So I need to go 4 high total and create that H on the graph. Like that. And then it says find the perimeter and area of your H shape. So every A is 1. This is 1, this is 1, this is 1. And likewise down here we have 1. And then the B, which is from here to here, that's 2. And this is half a B, so that's 1 there, 1 there, and so on. And now we can use that information to find the perimeter. We can just add up all the 1s and 2 all the way around. If you pause right now, you can go ahead and do that. But if you do it right, you should get the perimeter is 20. And then the area is, every square like this is 1 by 1, so that would be 1 square unit. And if you count them inside the H, you'll see that, oops, I kind of created my shape a little wrong here. Fix that. So, if you count the area correctly, you should get 9 square units. Now we're going to write an algebraic expression for the perimeter. To do that, let's just label a couple more parts. This is A, this is A, this is A, this is B, B, from there to there is B, from there to there would be B, because on the other side there has to be, and then this is half of B here, and half of B here. And so we have some like terms here. We can add up all the A's together. And I see 1, 2, 3, 4, 5, 6 A's. And then if we add all the B's, we get 1, 2, 3, 4, and those two together make 1B. And then, forgot those two there, but if we add them all up, we get 7B. So there's an expression for the perimeter. And the area, we need to multiply or split this up into little parts. Like this part right here would be, this is half. I'm going to use my original figure here to get the area. So let's split it like this. That would be B times A for that area. This area would be A times B also. That little area right in there is A times half B. All right, so let's finish this up. We could actually divide this up like this, and then we'd have 1B times A again, another AB there, another AB here. And then right here we just have A times 1/2 B. I'm going to write that as 0.5 AB. And then if I combine all those together, I get AB 4 times, 1, 2, 3, 4, plus an extra half. So 4.5 AB. Okay, now number 5 says use your expression from question 3 to calculate the perimeter when A equals 1 and B equals 2. So we're talking about this. And if A equals 1, we're going to do 6 times 1. B is 2, 7 times 2. And if we simplify that, we get 6 plus 14 equals 20, which is what we calculated the perimeter as before. Okay, now to find the area, we're going to take 4.5 times A. Again, A is 1, times B. I'm using this expression. B is 2, and 1 times 2 is 2, times 4.5 is 9. And that's the same as the area I got earlier. So how did you determine the algebraic expression for the area? We split up the shape. Split the shape into rectangles. And then use length times width on each part. All right. Now, all these problems have to do with creating expressions and simplifying those expressions. So I'll do a couple, and then the other ones we can do in class. But this first one, Rangley's father is making a walkway in the backyard. He will use large tiles for the walkway, like the one I write. Write an expression in simplified form for the perimeter. Perimeter means add up all the sides, so we need to add all of these. And remember, we can combine like terms. So the like terms that we have here are 6x, 3x, 5x, 4x, and 1x. And if we combine all those, we get 6 plus 3 is 9, plus 5 is 14, plus 4 is 18, plus 1 is 19x. And then the constant terms, the numbers without variables, are also like terms. And starting here with this one, remember, if you're subtracting, treat that as like adding a -2. So we have -2. In this one, there is no constant. We have another -2 here. We have a 1, and we have a 3. -2 minus 2 is -4, plus 1 is -3, plus 3 is 0. So all of those equal 0. So I'd have 19x plus 0, and 19x plus 0 is just 19x. All right. All right, so this is an amusement park. 2 families went to an amusement park together. The number of people in each family is listed on the table. The admission ticket costs $8 for each adult. I'm going to put A above that for the adults, C for the children, and S for the seniors. Write an expression in simplest form to show how much it costs for all adults, children, and seniors from the 3 families to attend the amusement park. So we want all of them, so I'm just going to combine these into one. So I'm going to put a total here at the bottom of my table. Total. So total adults is 5, total children is 6, total seniors is 4. 5 plus 6. And the expression is we need to multiply the number of adults times the cost per adult. And that's A. So the expression for the cost for the adults is 5 adults times $8 per adult ticket, plus we have 6 children times C dollars for each child ticket, plus 4 seniors times S for the price of each senior ticket. And then that's the expression we're going to use. And it says that we want to know how much they spent if they paid $40 for each adult ticket, $25 for each child ticket, $27 for each senior ticket. So we're going to take 5 times 40. We're going to substitute 40 for A, since that's the cost of an adult ticket, plus 6 times the cost of a child ticket, which is $25, plus 4 times the cost of a senior ticket, which is $27. And if we do that, we're going to get 5 times 40 is 200, plus 6 times 25 is 150, plus 4 times 27 is 108. And if we add those all up, we get $458 for the whole family. All right? Says using the number 8, give 2 different expressions that result in 16. Well, one thing we could do is just add 8 twice. That would give us 16. And I'm going to let you think of what the other expression would be, but you could just write it to represent. There's a shorthand way of writing what 8 plus 8 is, and it's not 8 to the second power. That's 8 times 8. And then you can rewrite your second expression too using n. So n plus n. And you're going to think of another expression that means n plus n. And we can do that in class. All right, if you go to the next page, there's one example I want to do there. And then the rest we'll do in class. And we've done a lot of these simplifying expressions, but I want to do one where we are subtracting a quantity, like number 15 here. And so you can learn how to deal with that. Maybe I'll do one or two examples. But so we have 2y plus 7 minus, in parentheses, 3 minus 5 plus y. Now, when you're subtracting a quantity like this, we can put, any times we're just subtracting a number, it's the same as subtracting 1 times that number. And subtraction is really adding a negative. So what we have there is a distributive property going on. So to get rid of the parentheses, you can just multiply -1 times each of those things inside the parentheses. So we would get -3y. And this is really a -5 there, and a -1 times a -5 is a +5 plus y. Now we can combine like terms. Those are like terms. 2 plus -3 plus 1 is equal to 0y. And then 7 and 5 combined make 12, so this simplifies to just 12. Right? I'm going to do one more like that where we use a distributive property with a minus sign. If we go to the next page here, we can find one. How about this one right here, number 14? 1 minus 4 and u minus 1. Again, remember when we're simplifying things that you really should take care of multiplication first before you add or subtract. So you wouldn't want to do 1 minus 4 until you multiply the 4 out. So think of this as adding a negative again. That's really a -4, and then we're going to distribute that. So we have to multiply it by both things in there. So I'm just bringing down the 1, but now I'm going to multiply -4 times u, which is -4u. And this is really a -1 here, adding a -1, and a negative times a negative is a +4. And then I can combine these like terms, and I get -4u plus 5. So -4u plus 5 is what that expression simplifies to. All right. That's enough for today, and I'll see you tomorrow.